Okay, last class, we have talked about some definitions on environmental science and engineering, and also some very minor things which we need to consider when we deal with environmental problems, right? So, well, before starting, I just give you some review here. What is environmental science? Well, we actually talk about science and engineering, the differences, at first class. Well, for the environmental science, we can say, in generally, this is the study of source, reactions, not source, and the transport effect, effects of environmental materials in water, soil, air, biota. So why is source, reaction, transport effects are important? Sam, politics?
Because all of them have made bad for our environment, like pollution. They make our environment unable.
Yeah, well, okay, well, the reason why we want to know the contaminant source, well, this is very, very important. Before fighting, before start the war, you guys really need to know the enemy, right? So the source of contaminants are very, very important. And the reaction, if there is reaction occur in natural environment, if it is, we don't have to put so much our effort on the reaction, right? Just make it, accelerate, and just to put it a little bit. First, turn off your mobile phone, please. So, knowing the environmental reaction is very, very important. And transport. If the environmental contaminants stay in one place and never ever transport it to other site, do we have to worry about that? We cannot say that is contaminant, right? It is well contained. For example, uranium, plutonium, in the deep in the ground, it cannot be easily exposed. Well, actually, God made it, right? Unless we dig them up, that's okay, right? So if we can control transport, well, we can solve the environmental problem and effects. Well, there are so many different factors to influence, to affect the fate of the environmental contaminants. As I already talked, fate is important. And also, if you think of the Earth, well, the Earth includes water sphere, and soil sphere, air sphere, and biota. What is biota? Bio, right? Including you and all the living organisms, right? So this is the study of all of this. And also, we especially focus on the movement, transport of the chemicals. Well, I'm very sorry. Is there any biology major student here? No? Well, we are actually chemical compounds, right? How do you know the components of the given kind? Make it
from the experiment?
Yeah, whatever. Well, actually, Nazi, army actually did it at Auschwitz, 67 years ago, actually. Just about the people hurt. Yeah, you can find the basic chemical components of human being, right? What is it? Carbon, oxygen, nitrogen, phosphorus. That's it. Right? Well, anyway, important thing is, where am I? Yeah, sometimes just forgot what I'm talking. Well, anyway, just focus on the movement of mechanical. So my focus was all things in the world, even our sphere, maybe out of the Earth, all of the materials can be described or explained by chemicals. So the chemical movement between environmental media, well, it could be air to water, air to soil, or soil to gas, like that. So if you know the transport of the chemicals, well, actually we can manage the environmental contaminants, contamination. So this is very, very important. By the way, what is the movement of the chemicals, contaminants, environmental contaminants between environmental media, air to water? What kind of chemical can be transferred from air to water?
Carbon?
Yeah, well, could you be much more specific?
Carbon dioxide could be dissolved to C, I think.
Can you say carbon dioxide is contaminant? Think about that. I'm just talking about the contaminant, right? What if we just remove carbon dioxide from the Earth? Can you live without carbon dioxide? Yeah.
I can live without carbon dioxide, but plants cannot.
Yeah. So we cannot say it, right, actually, right? Well, there are so many different, chemical components which are very soluble. The gases, for example, sulfur from the stack, or SOx, NOx from the vehicle. Those could be dissolved into the water, right? So that is very, very important. And also, environmental science is kind of quantitative science. The numericals are very, very important. So how fast and how much is very, very important. So this implies the use of numbers. Think about this. Can you say, well, I just talked to the Senate seminar student. I just gave the example. As I already taught, is the rice toxic chemical? Can the rice can be toxic chemical? What do you think about this? Oh, you cannot remember that, right? Well, think about this. If I just offer a bowl of rice for lunch, maybe 1 hour after this class, it could be very important and nutritious for me, right? What if I just order him, just open your mouth and put the 100 bowls of rice? What happened? He can get killed. So in that case, is rice able to be toxic chemical? Right? So what's the difference between the toxic chemical and the rice? It is the difference of the amount, right? So amount is very, very important. Yeah. Well, if you just put the very small, fish food, you just put it, or you just put it the milk over there and put it into the fish tank, and you can find the fish protein actually. So the amount is very, very important thing. So we should be very quantitative when we are dealing with environmental problems. And also, we need to do some tool skills to deal with these issues quantitatively. Some very tedious things we need to think about is estimating unit conversion and point process, and also resonance time. Okay, last lecture we have talked about some unit conversion, some important fixes from femto to TIR. So you can easily see F stands for the femto, and micro, mu, this is not M, mu, micro, and N milli, and C centi, and case, this is a small k. As you can see, all the minus term actually has small character, but the plus convention actually have large character. As you can see, this is k kilo, bk, right? Okay, and also we need to know some kind of unit conversion. There are two representative units, SI and English. Inch, 2.54 centimeter, and 1 pound, 10 to 3 kilometer, 10 to 6 gram. Well, actually, you guys don't have to memorize all of this conversion, English to SI, SI to English. Don't do this. And finally, I actually gave you very, very important, thing, how to research. Well, as this gentleman said, politics is very, very important. Yes, that's right. But believe me, please follow this simple protocol. You never ever regret. And after graduate and join other research group, although you have your own advisor, if you just follow this step, you can publish your experimental results that is significant journals. The first step is, as I already talked to you, you really need to find very significant environmental problems and then understand it. As I already taught, if you are a journalist, if you are famous, well, actually the skill is not that important. The most important thing is you need to find out what is the most important, issue, right? And make them very significant. That is very, very important. And then you need to understand it. Is it? If you cannot understand the problem, how can you solve that? Right? Then you need to simplify the problem. Well, you can have all boundary and initial conditions. Make them simpler so that you can solve the problem with ease. That is very, very important. Then set up the problem's hypothesis. This is very, very important. Some of you from science department, some of you from engineering, the student from science department, they are very familiar with this kind of protocol because they need to verify the hypothesis if you guys really want to graduate. But engineering department, this protocol is a little bit weird. But nowadays engineering school and science school is not that different. All the engineering professors are actually doing science research work, including me, and most of the physics professors actually doing engineering actually for the research. I'm not just kidding. And then solve the problem by experimenting. Well, you can use any types of analytical equipments, and you can simulate using mathematics and supercomputer, and you can solve the problems, and comparing and estimating and verifying. Voila! You guys can finally publish your experimental result at this June? Well, if you guys know the Nobel Prize winner very well, that could help. But mostly, this protocol is very, very important to you. I have this. Okay, let's do some simple example. The question. The question is just to determine the size, the height of an oil molecule. Well, actually, Benjamin Franklin actually poured 0.1 cubic centimeter of oil on a small pond in his backyard. I think he was very rich guy. He has his own, lake pond, and waited until it had spread over to cover the maximum area. If this area was 40 square meter, what was the size of molecule of this oil? This is very simple, right? Just pour the oil and then spread it, and then check the height of the molecule, right? So this guy is Ben Franklin. Where can you see him easily? Well, can you see him easily? Where can you see him easily? My question is, where can you see him easily? Do you have a dollar? Is he? Actually, he is the. Is he in the dollar? 10, 20, 100? Yeah, actually 100. Wow, wow. She knows the money. Although he is not the president of the United States, he was the model of the $100 bill. Actually, he is a scientist, he is a politician, and he is very kind to women. Actually, very nice. I really don't know. Actually, Wikipedia just described him as very gentle. So from this question, we know the volume and we know the area. So divided by volume area, and you can have the height of the molecule, which is 2.5 10 to minus 7 centimeter. Well, actually, you guys know the centimeter and angstrom. So if you multiply it, you can have 25 angstroms. The height of the oil molecule is just like 25 angstroms. You may think this is very silly, problem and a silly, answer, right? But if you just check all of the significant environmental problems, you may be very lucky. They just based on this silly equation. Wow! Can you believe this? How the professor or how the graduate student in KAIST, they are using this type of simple algebra, not the, huh? Yeah, it is just a linear algebra. 1 plus 1 equals 2. How they publish their experimental result using such kind of simple algebra for their publication at Science and Nature. Do we really need to use supercomputer to simulate some kind of environmental phenomena using not algebra, using very difficult mathematical gizmos? What do you think about this? Do we really need to do this? Although we can solve our problem with linear algebra. Well, you can use politics then.
But simple algebra will give us like approximate result, not true results, and big like mathematics, hard mathematics will give us really true answer. And in this experiment, yes, we can say that height of one molecule of oil is 25 angstroms, but in effect it's not. So,
all right, if you are using calculus and you are using supercomputer and you are using molecular dynamics, which I am, working on right now, or quantum physics, which I'm working on right now, to identify hydrate formation in Ullum Basin, is there any significant difference between the result by linear algebra and the results by the supercomputer? So why are we so tricked about using those kind of supercomputing system if we can solve the problem with simple algebra? Is it that significant? Maybe 0.05 angstrom difference. Maybe those difference can give me, Nobel Prize. Well, I buy your point.
You said that volume has volume is important. So 0.05 extremes is also important.
Yeah. Well, that is what I think engineer buy it very seriously, because engineers actually very good at mathematics, numerical, analysis, and numerical, because think about this, we really want to take the people to the moon, right? If we are just using experiment, let's say, all right, I just designed one, rocket with solid fuel, maybe nitrogen, hydrogen, and here is the moon, and the rocket actually do something with pestle and mortar, all right? Then we just take some people here, including Mr. Armstrong, or some more. All right, the first time, just put the 100 ton of solid propellant. And we just put the fire on it, and it goes. Unfortunately, the fuel is, inline, they just fell down. Huh? So the NASA, scientists decided to add some more propellant. At this time, it's too way much, so we cannot, return actually. So do you want to continuously conduct this experiment? So every time I need to, if I am the head of the NASA, I need to go to their wives and then or their husband. I need to say sorry to them, right? Your husband and your wife actually do something good for nation. So if we really don't do this, what we want to do, we can simulate using a supercomputer. Maybe the angle of the propelling state is very, very important. Maybe 0.2 degree can bring the people to Earth again, or we cannot see them anymore, right? So the solution and the solving approach is very different depending on the character of the problem, right? Okay, well anyway, at this point, as I already talked, Ben Franklin is very nice to rate this actually. I really don't know what that means, but Wikipedia just describe him as a gentleman. Don't forget that. Do nice to ladies, right? Okay. This is one more example. You do this one. Well, actually, from now on, I put all of the lecture video clip and homework, and also all of the materials. I put it homepage of my research laboratory. I just give you the address, and you go to the homepage and click there, and you can find many interesting information there. Well, this is a kind of silly question too, but it could be very informative. So please solve. All right. Okay, estimation. We often need to. Well, actually, most of the people actually guess, every second and for many things in the environment. So guessing and assumption is very, very important. If you have good guess or good assumption, well, your results are very exact, and you can get very proper answer. So let's do some example. How many cars are in there in the United States and in the world? Well, I'm not just a mathematics teacher, so I'm not gonna I just don't show any answer just like the mathematics teacher. I will just give you a question and I will show the answer right away, right? Well, you may think this is very silly, but I'm just selling the silly problem and silly answer. The point is, I really want you to know how to approach it. That is very, very important. Although this is very simple, silly question, if I just remove this and put this one in midterm exam, well, I'm sure half of you cannot have right in the grade, actually. Right? Well, anyway, let's look at the solution. In the United States, 280 million people live there, and they have car every other person per the car. So if you just multiply 0.5, and you can estimate the number of cars in the United States. And this is another assumption. The U.S. economy is about 1/3 of world's. So if you multiply by 3, and you can have you can estimate the car of the world. Well, I usually talk to the people when I give presentation, and somebody can raise their hand and they ask me, is that the right thing? Do you think this is right? I usually talk to them, this is better than nothing. Better than nothing to do. That is very, very important. Do, and then judge. Right? And the next example is, I think,
May I ask? Like, our question was how many cars are there in USA, but if we don't know the information about 280 million people and
you should know that. You should know that. At least you know that you are not from United States, right? Well, where are you from?
Ukraine.
Ukraine. So, do you know the number of people in Ukraine?
Yes.
So?
But I don't know. Okay.
Yeah. That's all I want. Right. Now, some will estimate how many people work at McDonald's in this country, Ukraine. There is a McDonald's restaurant, right, in Ukraine, right? So, would you please stand up and explain your estimation to their,
What?
yeah, or if you need blackboard, no, the white, the board here, you can use it. Right.
There are many different ways to estimate the amount of people in McDonald's, and one of them is to take area of McDonald's, to take place of seats, and to take standing places where people stand and buy something to eat. Here we can use density of people for 1 square meter and calculate amount of seats here and just plug them. Okay?
Sam, you don't have to spend much time on the, well, you can just guess maybe 20, McDonald's crew working at the one restaurant right now. Just give assumption,
Assumption. Oh, then
Yeah.
my final version and my final estimation was, we know the amount of employees per month, how many people visit McDonald's per 1 month, and we can multiply it by amount of employee and find average and find the average per 1 day, and then it will be the answer.
Well, I think that is very important point, thinking about the time. But at this point, at this moment, we just forget the time thing. Time is just to remove the time factor. Yeah.
We can remove it, and we will still have an answer.
Yeah. So can you give some? As I already told, environmental science is the science of quantification, right? So we want the number.
Number?
Yes.
Will we count some number? I don't know. Okay, if there are 1,000 employees every month, and one worker of McDonald's have 1,000 of employees every month, and there are 30 workers in McDonald's, so it's 30,000 people every month, and per 1 day it's 1,000 people.
1,000 people working at McDonald's, right?
And it's 1,000 people every day, and it's something around 25 people per hour, 40 people per hour, and if it's dinner, it's a little bit more.
All right.
In the
So,
dinner, it's 50
thank you very
people.
much for your efforts. Well, give him a big hand. Well, important thing is, giving right number is very important because you are a scientist and you are an engineer, right? But the important thing is, as I already taught, learning how to approach is very, very important. Setting a hypothesis is important, and setting assumption is important. Before those, understanding, the problem is very, very important, right? So, what is the answer, from the text? Let's just estimate the number of the McDonald's crew in the United States. Step one. Well, there is some. Well, actually, this book was written by Ron Heitz. Well, he is professor at Indiana University. Bloomington is the city of Indiana University. So Bloomington, Indiana, it is just like very small local town. Has 7 McDonald's restaurants serving a population of 70,000. So ratioing this to the U.S. population as a whole, I cannot believe this. 50 employees, working at one McDonald's restaurant. Do you believe that? 50. Hey, in this classroom, we actually don't have, 25. It's just like 26, including me. And 50 McDonald's crew working in one McDonald's restaurant. I really believe that. But Ronnie Heights just guess like this. So believe him. Put credits on it, right? So assume 50 employee works for one McDonald's restaurant. So one McDonald's restaurant actually covers 10,000 people, right? And the number of per United States, citizen, we multiply this number, we can have 2.8 times 10 to per McDonald's restaurant in the United States. And then, as a relator, one restaurant, there are 50 employees, right? So we multiply this ratio to the number of restaurants in the United States, we can have 10 to 6 employees in the United States. Wow! It is just like less than 1%, is it? Because it is just like 10 to 8 is the number of per United States citizen, and 10 to 6 is McDonald's employee, right? So think about that. So you cannot get it right. So if you set up wrong assumption, you cannot get the right one. So, well, do you think what kind of assumptions wrong? As a writer, I really don't get the assumption of this one. Maybe just think about Korea. If you just enter McDonald's restaurant, you can see maybe 3 or 4 McDonald's crew at the counter, and near the counter there is prime deck, right? I'm sorry, I'm not the representative of McDonald's, but I'm just talking to you based on what I'm observing actually. There is prime deck. There are always one or two people there, right? So 6, and in the kitchen there are maybe 3. So the total number is 9 or 10, right? If you put the 9 or 10, you may have different numericals actually. So the assumption is very, very important. Think about that. Well, nowadays, CO2 emission is the problem, right? All right? You may pay money if you emit CO2 or greenhouse gas. Just don't say, I am not producing, greenhouse gas. You are producing actually. Methane, you are producing actually, right? So if you produce the exceed amount of the greenhouse gas, you need to pay your money, right? So all the countries nowadays are very, worry about how to calculate. Think about that. If you underestimate or if you overestimate, you need to pay your money differently, right? If you check the some kind of estimation method, there are so many different, estimation method because their assumption is totally different. Think about that. The emission of CO2 from Honda car, let's say Accord, Honda Accord, the equivalent level is maybe Sonata from Hyundai, right? But the emission of CO2 during the production of those two cars are totally different. Which one is higher? Mr. Bang? Yes?
I cannot understand that.
Anybody who understand my question? Beck? Is it Beck? Beck? Bach? I'm sorry. Because I don't have time, I just well, my question was, well, actually, the production of CO2 during the, emission of CO2 during the production of a car is different depending on the nation. Japanese car and Korean car, Hyundai and Nissan or Toyota have different evaluation. Maybe Toyota Camry is just like the Hyundai, what's that, Sonata, right? So my question was, which car actually emit lower CO2 based on their estimation calculations?
I think it's my point of view. I think,
Mhm.
of course, Honda is emits much more CO2 than
Why? Because the answer is right. Why?
because the size.
No, let's just assume all of the things are the same. The production lines are the same, and the emissions are the same. The workers' number same, and the electricity they are using the same. So what's supposed to be the problem on the differences of those two estimation amount of CO2? I think I already answered you guys, because Korea and Japan have different estimation method based on different assumption. So United Nations want to unify it, but the problem is no nation want to unify it. Japan, Korea, never ever, because we need to pay money. So assumption is very, very important. Okay, so we have important 1%, maybe around the 1% of the of the people in the United States, they are working for McDonald's. So McDonald's are great, restaurant in the world. Although I'm not the representative of the McDonald's restaurant. Right. Now, how many footballs can you be made from one pig? I really don't know. I never ever heard about football was made from the pig skin. But you estimate how many footballs can be made from one pig. This is in home page. I will put it on my homepage. Alrighty. You can see the just like this guy is just look like in mind an animal. Right? I well, isn't anybody who from Italy? I'm very sorry. I really don't have any intent to disrespect this scientist. His name is Amadeo Avogadro. You guys may know his name from the Avogadro's number, right? So, somebody just painted his face, 1856, and this guy actually, gave very significant impact on gas law. So we are using ideal gas law, PV equals nRT. P, pressure. Well, this could be atmosphere, and it could be torr. As you guys know, one atmosphere equals 760 torrs, and volumes are in liters, and N is number of moles. Well, this is Avogadro's, the famous Avogadro's number, 6.023 times 10 to 23. You really need to memorize this. And whenever you met your girlfriend or boyfriend, just to remind them, do you know the number of the Avogadros? Just ask them, And if they say no, just let them know. This is very, very important, And R equals gas constant. It is 0.082 liter atm degree reciprocal. Temperature in Kelvin. Well, you can calculate it with Celsius by adding 273. Right. And composition of the Earth is very, very important. Well, you guys know 78% is composed of the nitrogen, and 21% oxygen, and 1% argon, and 306. Well, actually, percent is pph, parts per 100, right? and ppm is parts per million. So if you want to convert it, you need to divide by 10,000, right? pph in ppm. This is very, very important. And CO2 is 360 ppm, and neon 18 ppm, helium 5.2 ppm, and also methane 1.5, and krypton as 0.5 ppm. Well, this is the reason why the Superman can be Superman on the Earth. Based on this information, if you can go other planet with very small amount of nitrogen, can you guys be a Superman or Wonder Woman? Can it be true? So is there anybody who can, explain the hidden assumption you guys can be Superman and Wonder Woman? Anybody here? All right, that's it.
Because alien molecular structure another from ours, and they will think that we are Superman or Superwoman, but in effect we will be like this, just normal in our planet, but in their planet we will be like the Superman.
Okay. All right. Is there any opinion against it, or? I don't think those guys understand what you're talking. Actually, I just understand what you're talking, but they cannot buy it anyway. All right. Let's move on, and then we will talk about it later. All right. Here, percent pH and ppm and ppb, or on volume per volume basis. This is very, very important. So nitrogen here 78% means 78 liter of nitrogen per 100 liter. This is not 78 gram of nitrogen per 100 gram. This is very, very important. This convention applies to all atmospheric concentration, but not water and solid, but by because they are using actually mass. This is very, very important. So in the atmospheric environment, we are using volume basis, and other environment, they are using mass volume, mass basis. All right. Okay. I think there are some useful. I will do it later, and I'd like to introduce some useful side here. Well, as I when I talk to you, I put it all the homework set assignments and syllabus. Syllabus will be changes, and previous lecture video clip, and you guys can check it, and even you guys can ask me if you have question, or you can call teaching assistant. I think she's better than me in environmental chemistry. Or if you really want to ask and want to consult with me for your future career, near future or long future, well, you are very welcome. All right. So visit Environmental Geobiochemical Research Laboratory, EGRL. This is one research group, actually. I don't know if this can be connected or not. Let's see. All right, we'll do that. All right, it goes. You can see the EGRL homepage here, and just go to the lecture part. Okay, you can see the syllabus part. If you click you can actually download it and lecture note Word. Okay, here it goes. And this is the previous lecture video clip. You can get it actually, right? So just download it and disseminate to all the audiences in the world. Well, actually, I actually don't put it my copyrights, but if you just disseminate it to the people you want, just let me know, all right? Unless I will sue you. This is very, very important. Okay, and also there is a question and answer part. Well, I will develop more here. So you guys can ask me and directly or using this in the laboratory homepage, right? Well, anyway, I think
Can you give us a website where we can find PPTs?
I also upload my PPT files. Well, actually, the first time he just visited my office, I just told him, I never ever make my own PPT. There's no PPT. I will write, using chalk on the board, but I think that is too tough for him. So I will make it and I will put it on homepage. All right, finally, this is the text for environmental science. And I will continuously talk to silly questions and silly answers which can improve your knowledge, basic knowledge of environmental science, actually. Maybe 7-8 weeks. Then I will be a little bit more serious and strict. I'm using this one. This is environmental engineering science. Well, I will do environmental engineering with this. So maybe 5 weeks, 6 weeks, you guys will run environmental engineering. Please don't purchase this one. I will, upload the lecture note, PDF files. But just don't disseminate PDF files. That is against the copyrights, right? Because I was writing this book too. Yeah. And I think you can check it at the bookstore right? I'm not the representative of John Wiley, but this is very, very important. They actually don't pay me $1 anyway. So, but this is very wonderful book, I think. All right, is there any question or comments? Any compliment or any punishment on the lecture material today? You always made me my, lecture complete. No question. Everybody can do it. Wow. Anyway, have a nice weekend.
감사합니다.